Hello and welcome to Genesis Training. This is your trainer Kaustav. This is the fourth video in the series of time, speed and distance. And in this video, we'll be dealing with a very important subtopic of time, speed and distance, that is problems on trains. Let's start off with the concepts and then we'll move on to the problems. Now, when it comes to train problems, there are basically three types of problems. The first such type is when two trains are moving towards each other. This is train 1, this is train 2. The length of this train is L1, the speed of this train is S1. The length of this train is L2, the speed of this train is S2. Now they'll ask you to find the time taken by the trains to cross each other. Time taken is nothing but distance by speed. Always remember, the distance traveled by the trains while they cross each other is always the sum of the lengths of the trains, no matter which direction they are going, divided by the speed, more importantly relative speed. Now we saw in the previous video that when two entities are moving towards each other, that is in the opposite directions, then the speeds get added. So we have S1 plus S2. Now if the two trains were moving in the same direction, we have L1, L2, we have S1, S2. Then the time taken by them to cross each other would have been L1 plus L2 divided by S1 minus S2. The distance stays the same, but the speeds get subtracted because, like we know, that when two entities are moving in the same direction, the relative speed is the difference between the two. Okay, so this is case 1. In case 2, there is a train and there is a bridge. Sometimes there is a bridge, sometimes there is a platform, sometimes there is a tunnel. So the train is moving this way, length of the train is L1, speed of the train is S1. Length of the bridge is L2 and speed of the bridge is 0, obviously bridges don't move. So the time taken by the train to cross the bridge is L1 plus L2 divided by S1. So whenever there is a bridge or a platform or a tunnel, you can treat it as another train which is standing still, which is not moving at all. Okay. Now we have case 3. In case 3, there is a train and there is a person. Suppose they both are moving in the opposite directions. Length of the train is L1, speed of the train is S1, speed of the person is S2, length of the person is considered as 0. We consider it as 0 just for ease of calculation because with respect to the train, the length of the person is negligible. So time taken by them to cross each other would be L1 divided by, because L2 is 0, S1 plus S2. And if both of them are moving in the same direction, then it will be S1 minus S2. That's it. So this is the concept behind train problems. Let's get started. Two trains having lengths of 140 meters and 160 meters run at speed of this much speed and this much speed respectively in the opposite directions. The time which they take to cross each other is what? Okay. So time equals distance by speed. Distance is obviously the sum of the lengths of the trains, 140 plus 160 divided by. What is the relative speed? Obviously they are moving in the opposite directions, so we add the speeds. We have 60 plus 40. But this is not final because 140 and 160 are in meters, 60 and 40 are in kilometer per hour. We need to match the units. And how do we match the units? We look at the options. All the options are in seconds. So we need to convert kilometer per hour to meter per second. We are going from big to small. So we multiply with 5 by 18. Let's calculate this. We have 300 divided by 100 into 5 into 18. 0, 0 gone. 54 divided by 5, that is nothing but 10.8 seconds. Answer is D. That's it. You just needed to focus on which direction they are moving. Distance is anyway the sum of the lengths of the trains. Let's move on. A train 125-meter long passes a man running at 5 km per hour in the same direction in which the train is going in 10 seconds. The speed of the train is how much? Okay. So in the same direction, so the speed of the train minus the speed of the man. The man is running at 5 km per hour. 5. Minus because same direction. Speed equals distance by time. Distance is always obviously 125 meters divided by time is 10 seconds. Now all the options are in kilometer per hour, so we need to convert this meter per second into kilometer per hour. Meter per second to kilometer per hour. We are going from small to big. So we multiply with a bigger number. That is 18 by 5. So 5 2s are 10, 5 25, 5 5s are 25, 2 9s are 18. That is 45. Speed of the train is nothing but 45 plus 5, that is equal to 50. That is the answer. Answer is bravo. Alright, again make sure you match the units and you always keep your eyes out for same direction or opposite direction. Let's move on. The length of the bridge which a train 130 meters long and traveling at 45 km per hour can cross in 30 seconds is what? Okay. So we have the length of the bridge plus the length of the train, that is 130. This is nothing but the distance. Distance equals speed into time. Speed is 45 km per hour into time is 30 seconds. Now again there is a mismatch of units. This is in meters, this is in seconds, this is in kilometer per hour. All the options are in meters. So let's convert kilometer per hour to meter per second. We are going from big to small, so let's multiply by 5 by 18. Now 9 5s are 45, 9 2s are 18, 2 15s are 30. So 25 into 15 is nothing but 375. So the length of the bridge is nothing but 375 minus 130, that is equal to 245 meters. Answer is C, 245 meters. Alright, that's it. Let's move on. Question number 4. Question number 4 is a combination of all the previous 3 questions. Here there is a train, there is a man, then there is a platform, and then there is another train. So everything is there. Let's go slow with this. A train crosses a man in 9 seconds. Now they have not mentioned that the man is moving, so we assume that the man is not moving. This means that the length of the train divided by the speed of the train equals 9 seconds. Now the same train crosses a 240-meter long platform in 24 seconds. So length of the train plus 240-meter long platform divided by speed of the same train equals 24 seconds. Alright, so we have 2 equations and 2 unknowns. Let's solve them. Length equals 9s. We substitute this over here, we get 9s plus 240 equals, s goes over here, becomes 24s. 24s minus 9s is nothing but 15s equals 240. S equals 240 divided by 15, that is nothing but 16 meters per second. So the speed of the train is 16 meters per second. Let's find the length of the train. Length of the train is nothing but 9 into 16, that is 144 meters. So we have the speed of the train, we have the length of the train. Now they have asked that this train is crossing another train of 256 meters length and 12 meter per second speed in the same direction. What is the time taken by them to cross each other? Let's do that. Time equals distance by speed. Distance is the sum of the lengths of the trains. We have 144 plus 256 divided by Same direction, so we need to subtract the speeds. We have 16 meter per second minus 12 meter per second. We have 400 divided by 4, that is 100 seconds. That is the answer. Answer is D. So this one is a slightly time consuming question, but if at all you practice this again, if at all you can solve this one accurately, that means you understood the basic and the intermediate level of relative speed as well as train problems. Let's continue. The Alpha Express left Pune for Mumbai at noon sharp, that is at 12 o'clock. 2 hours later, that is at 2 p.m., the Deccan Queen started from Pune in the same direction. The Deccan Queen overtook the Alpha Express at 8 p.m. Find the speeds of the two trains over the journey if the sum of their speeds is 70 km per hour. Now again, in these kind of questions, what we do is we try to figure out which entity is constant. Is it the speed? No. Is it the time? No. Is it the distance? Yes. Both of them started from Pune and both of them met each other at the same point, obviously. So the distance traveled by them is same. Distance traveled by the Alpha Express equals distance traveled by the Deccan Queen. Distance is nothing but speed into time. So speed of A, time of A equals speed of D, time of D. Now they have mentioned that the sum of the speeds is 70. So we have SA plus SD equals 70. Let SA be SA. Time of A is what? Alpha Express started at noon and met the other train at 8 p.m. So the total time period of the journey is 8 hours equals. Speed of the Deccan Queen is nothing but 70 minus SA according to this into time of the Deccan Queen is 2 hours later, so 2 p.m. to 8 p.m. that is nothing but 6. Okay, so we have one equation and one unknown now. Let's find it out. We have 8 SA equals 6 into 70. Let's just write 6 into 70 minus 6 into SA. This goes over here. 8 plus 6 is 14 SA equals 6 into 70. So we have SA equals 6 into 70 divided by 14. 14 5s are 70. 6 5s are 30. So the speed of the Alpha Express is 30 km per hour. Speed of the Deccan Queen will obviously be 70 minus 30, that is 40 km per hour. 30 and 40. Those are the answers. Let's move on. Without stoppages, a train travels a certain distance with an average speed of 50 km per hour. With stoppages, it covers the same distance but with an average speed of 40. Why is the speed reducing? Because of the stoppages. The time is increasing but the distance traveled is same. That is why the speed is decreasing. How many minutes per hour does the train stop? I'll tell you a beautiful shortcut to solve such questions. In such questions, all we need to do is, first we need to find the difference between both the speeds, that is 50 minus 40. Then we need to divide it by the original speed, that is 50 without stoppages. So this is how much of the duration the train stopped. Okay, how much of the duration the train stopped? That is nothing but 10 by 50, that is 1/5. 1/5 of the time the train stopped. Now they have asked how many minutes per hour does the train stop. So 1/5 of the entire journey the train stopped. So 1/5 of 1 hour. 1 hour is 60 minutes. 60 by 5 is nothing but 12. 12 minutes per hour the train stopped. Answer is C. So difference between the speeds divided by the original speed into 60. That is all you need to do in order to get this question. Within 10 seconds flat, you have the answer. So these were the different types of train problems that you might face during the tests. Thank you so much. I'll see you in the next video.